Hello, in this video we are going to learn how to use Cramer's rule to solve a system of equations. So let's begin exploring what Cramer's rule is. Say we have a system of equations. We are going to take our coefficients of a of x, y, and z and turn them into a matrix. And so we have our coefficients A1, A2, A3. Those are all of our x's. They're all going to create a column. Then we have our coefficients B1, B2, and B3, which are coefficients of y. They are going to create a second column. Then we have the coefficients C1, C2, C3, and they are going to create a third column. Then we have our solutions, D1, D2, D3. Well, not our solutions, our answers. Our answers to the system, to each individual equation. They're going to create their own matrix, D1, D2, D3. So now we are going to set up a determinant for D sub x. So we took our first matrix, A1, A2, A3, B1, B2, B3, C1, C2, C3. But because this is x, we're going to remove our x coefficients, and we are going to replace them with our answers, D1, D2, D3. Then you would find the determinant of this matrix. We would do the same thing with y. This time we're going to remove our coefficients for y, which is B1, B2, and B3. Remove that middle column and replace it with our answers. And we'll do the same thing with dz. Remove the coefficients for z, which are the c's, and replace them with the answers. Now, to find our actual solution, you will have to find the determinant of the regular matrix A1, B1, C1, A2, B2, C2, A3, B3, C3, and you're going to have to just say your determinant of x, d sub x divided by d sub y divided by d, and d sub z divided by d. So let's look to see what an actual problem looks like. We are going to solve the system using Cramer's rule. We have the system here, 5x minus 3y, missing a z, right? Make note of that. 4x minus 6y minus 6z equals 6. Negative 5x plus y minus 3z equals negative 2. We need to turn this into two matrices. So first, we need to pull our x coefficients. 5, 4, negative 5. They all become a column. We're going to do the same thing with our y coefficients. Negative 3, negative 6, and 1. And with our z coefficients. Now, we're missing a z in the first equation, so in its place goes a 0. So 0, negative 6, negative 3. And in its own matrix goes our answers, 0, 6, and negative 2. So we need to set up d sub x. So we're pulling down all three columns, 5, 4, negative 5, negative 3, negative 6, 1, 0, negative 6, and 3. Now this is d sub x. So we're going to remove our x coefficients and replace them with our answers. 0, 6, negative 2. You will find the determinant of this matrix. D sub y, we're going to do the same thing, except this time we're going to remove our y coefficients and replace them with our answers. You will also need to find the determinant of this matrix. We're going to do the same thing with d sub z, but we need to remove our z coefficients and replace them with the answers. And we're going to find the determinant of the regular matrix, of our original coefficient matrix. At this time, you can pause the video to find the determinant of all three matrices. If you are unfamiliar with how to find the determinant of a 3x3, you need to go back to watch the video that is finding determinants of matrices. Okay, I hope you paused the video to find the determinants. Let's actually see what they were, see if you were correct. D sub x is negative 90, d sub y is negative 150, d sub z is 96, and d is negative 6. Now, if you tried to plug in negative 90, negative 150, and 96, you would not have gotten the correct answer because we have one more step to go. Our solution requires to take each of these determinants and divide it by the regular determinant of d. So negative 90 over negative 6, negative 150 over negative 6, 96 over negative 6. Simplifying, we get 15, 25, negative 16. If you plug these in for x, y, and z, for all three equations, all three will work. Example 2. We're going to continue using Cramer's rule to solve the system of equation x plus 4y plus 2z equals 11 negative y plus 3z equals 1, and negative x minus 6y plus 4z equals negative 3. First, we need to make our coefficient matrix. Looking at our x's, we notice that our first x has a coefficient of 1. We're missing our second x, that's a 0, and our last x is a negative 1. Looking at our y's, we see 4, negative 1, negative 6. And looking at our z's, we see 2, 3, and 4. Our answer matrix is 11, positive 1, negative 3. So we need to set up our dx. Remember, we are using d sub x, so we need to remove our x coefficients and replace them with our solutions. D sub y, we need to remove our y coefficients and replace them with our solutions. And d sub z, we need to move our z coefficients and replace them with our solutions. And then remember, we have to find the regular determinant of our coefficient matrix. So if you want to find the determinant by yourself, go ahead and pause the video here to find the determinant. Okay, now, hopefully you paused the video. We see that d sub x, the determinant of d sub x is 84. The determinant for d sub y is negative 18. The determinant for d sub z is negative 6. And the determinant for d is 0. Remember, when we find our solutions, we have to say d sub x divided by d sub y divided by d, and d sub z divided by d. So that looks like this: negative 84 divided by 0, negative 18 divided by 0, and negative 6 divided by 0. But we know that we are not allowed to divide by 0. Therefore, this system of equation is no solution. And that concludes this video on Cramer's rule.